Our integrating project is the design of a tariff model for heavy cargo transportation. Our work team is composed by the champions who are professionals with more than 15 years of experience in the logistics sector and the industrial engineering student Jennifer Murillo and Dan Nosaka, who lead the project in a business association that has 32 years of legal life in which they have to work to strengthen the logistics sector. The scope of the project will be to develop a software through the analysis of the critical variables in heavy transportation on the main routes of the country. We have to remember that the transport of heavy cargo is about the mobilization of goods that weigh more than 3.5 tons. The interviews with managers and consultants that were carried out by Microsoft Teams serve to identify that there is a discrepancy about the cost that should be considered for the calculation of a fair tariff. So that the Ecuadorian companies of heavy cargo transport establish the value of its service empirically. Faced to that, a proposal for a tariff model for heavy transport will be designed in Ecuador during the months of October to February 2021, which will be used by business association to train heavy cargo carriers. Through the use of a VOC, the needs of the clients were identified that will be translated into technical specification with the QFD methodology. The response variable of the model is the rate, which is calculated according to the total fixed expressed in tons or kilometers according to the needs of the clients, plus a percentage of profit. But the model and the interface were developed considering the quality and quantity of the existing information and the limited time. The organization has limited resources and low availability of computer equipment, as well as the carriers do not have much experience with new technologies. So the program shouldn't be very complex. The design options are represented below and will be validated at the end of the project. Once the problem has been detected and the solution established, which is the design of a rate model, then the information is collected through a data collection plan. There are several options for design models such as linear, step, and route-based function model, which are differentiated by the precision, which is given by the number of variables they involve, with the route-based model being the most complex and accurate as it considers the cost of tools, route condition, route geography, which affect the components as follows. The condition of the road affect the performance of the tires according of the percentage of potholes they present. For a road without potholes, the performance is 100%. For a road with less than 50% of potholes, the performance decreased by 25%. The state of geography affects fuel consumption. Fuel consumption will be the double for a hilly road compared to a flat road. Afterwards, a comparison of means of the rates was made in each model, and according to the p-value, it can be seen that the rate differs depending on the model used. Based on this analysis, the information, and the limited time for the development of the project, it is chosen to develop a tariff model based on routes for a T3S3 vehicle, which considers the monthly fixed cost, variable cost, the state of the route, the geography of the route. The software can be designed in several applications which have several characteristics. The importance has been rated by the customers. In addition, an economic analysis based on the VAN was performed, so Microsoft Excel is chosen.
The technical specifications are related to each of the design objectives and then is validated according to the implementation plan. First objective, design a friendly interface for the user. For this objective, the following technical specifications are taken into account. Like flexibility, the model offers the action of calculate a rating for any type of transport as well as specific vehicles. Quick response, the user only enters the necessary data. The response time is immediate or in a matter of seconds, and efficiency is related to the quick response of the software. And reliability, when comparing the calculate value with the real value charged by the carriers, a 6% error was uptime. And the third objective is design a standard tariff model for the transport of heavy cargo. The model to be developed must meet the common characteristics for calculating the rate. Where the most used type of vehicle is established, the business routes, the state of the routes, the geography, and this model has a cost structure with fixed and variable costs. Second objective, we use design of experiments with the variables that most affect the cost per trip with 7 factors with 2 levels and a replica. And this design determines the most significant variables for the model, as well as the interaction between factors that increase the cost of the trips. As you can see here, for example, for fuel, the price can range from the 1 to 1.06, so that the cost per freight varies from 0 to 1%. Now you can see several evidence about the validation that were carried out. And finally, we have the benefits of time reflect into the 3 pillars of sustainability. In the economic pillar, we have reliable cost structure and facilitates the negotiation of carriers, ensures a rate above the break-even point, and carriers say around $6,440. This value is calculated according to the hours invest by those in charge of the project. And for social, we have training of the proposed methodology, reduction of stress when setting the price of the service, and environmental efficient use of resource as a consequence of knowing the effects of certain factors on fuel consumption. For example, the geography of the route and the driver's experience increase the fuel consumption, and by understanding this effect, consumption of fuel is reduced. Thank you very much.